In the preceding video, we discussed measurement scales commonly used in healthcare data, explored steps for defining variables in SPSS, and assigned exercise 1, which focused on defining variables within SPSS. Please subscribe and click the bell icon to receive notifications when new videos are released. In this video we show how to enter data in Data View window of SPSS and how to effectively screen or clean and prepare the data for statistical analysis. Entering and screening data in SPSS. After defining the variables in SPSS, we need to navigate to the Data View window and carefully input the study data. Naturally, when dealing with a large number of samples requiring manual data entry, inevitable errors may occur in data entry. In such instances, employing data cleaning or screening techniques becomes necessary to identify and rectify invalid data entries. While conducting research online or storing patient medical records on servers reduces the likelihood of data errors, it remains essential to clean the data prior to commencing statistical analysis. As you can observe, the data has been inputted into this file. The variables within this file encompass patient's gender, received diagnoses, patient's insurance status, their income quartile, and their responses to questions 1 to 10 of a researcher-made questionnaire regarding adherence to medical recommendations. Notably, questions 1 and 2 gauge the patient's general treatment compliance, while questions 3 through 10 pertain to adherence to specific medical recommendations. It's important to mention that the questionnaire items employ a Likert scale ranging from complete non-compliance equals 1 to complete compliance equals 5. The values of the Likert scale are not defined in the value column as they are not utilized as ordinal variables in this study. We intend to aggregate the responses and compute the total score for each subscale. In such cases, the absence of defined ranking categories in the Likert scale does not pose any issues. A close look at the data file shows that there are some missing data and in some cases there were errors in data entry. We will fix these errors using data cleaning methods. Running the frequency command to find errors in data entry. Click the Analyze menu, point the cursor to Descriptive Statistics and then click Frequencies. The Frequencies dialog box opens. In the box with variables name simultaneously press Ctrl and the letter A to select all the variables in the box. Next hold Ctrl and click the case number variable in the left-hand box to exclude case number from the selected list of variables and then click the blue arrow to insert the entire selected list to the Variables box and then click OK. The first table in the output titled Statistics shows the number of missing values for each variable in the study. Below the Statistics table, there are several tables showing frequencies separately for each variable. Carefully examine the frequency tables to find invalid data caused by errors in data entry. Write down the invalid data information on a sheet of paper so that you can correct them later in the Data View window. For example, 44 is invalid in the diagnosis variable and it have to be replaced with 4. Also, in the Q2 variable, 22 is invalid and number 2 should be entered instead. Running Find and Replace to correct the data entry errors. To correct invalid data entries in the Data View window, follow these steps. Open the Data View window. Click on the Diagnosis column to select it. From the ribbon, click on the Find option represented by a binoculars icon. In the Open dialog box, select the Replace option. To replace the invalid data, such as 44, with the valid data, such as 4, input 44 in the Find field and 4 in the Replace with field. Click Find to locate instances of 44 in the Diagnosis column. Click Replace to replace each instance of 44 with 4. Additionally, to address another invalid data entry in the Q2 variable, click the Q2 column. From the ribbon, click the Find option with the binoculars icon. Next, select the Replace option. Enter the invalid data, such as 22, in the Find field and the valid data, such as 2, in the Replace with field. Click Find to locate instances of 22 in the Q2 column. Click Replace to replace each instance of 22 with 2. Filling system missing cells with -9. As mentioned earlier in the previous video, while SPSS recognizes its own system missing cells effectively, it is advisable to input a numerical value instead of relying solely on system missing. This numerical value should fall outside the range of the current study's dataset. In the present dataset, I have already designated -9 as the missing value. Now, I will demonstrate how to input -9 into system missing cells. Click Recode into Same Variables from the Transform menu. In the opened window, simultaneously press Ctrl and the letter A to select all the variables in the box. Now while holding Ctrl key, click the case number variable to exclude it from the list of selected variables. Then click the blue arrow so that the selected list enters the numeric variables box. Click Old and New Values, and in the opened window, select System Missing option in Old Value box and type -9 in the Value field in New Value box and then click Add. Click Continue and OK. You can see that -9 values are inserted in System Missing cells now. The Recode command for reversing the scoring of a questionnaire item. While many questionnaires implement a mix of reverse and regular scoring methods, it is advisable for survey implementers to enter all questionnaire items according to a single scoring method, preferably regular scoring. This approach simplifies the process of reversing the scoring of negatively worded questions, requiring only a few simple clicks in SPSS. In the present study, an example of reverse scoring is evident in Item 5 of the Adherence to Medical Recommendations questionnaire. To reverse the scoring method, follow these steps. From the Transform menu, select Recode into different variables. Next, choose Question 5 and click the blue arrow to move it into the box titled Numeric Variable to Output Variable. In the Output Variable box, designate a new name for the variable to be created in the next step. For instance, select Q5R and click the Change option. After selecting Old and New Values, follow these steps. In the opened window, enter 1 in the Old Value box and 5 in the New Value box, then click Add. Next, enter 2 in the Old Value box and 4 in the New Value box, and click Add. Then, enter 3 in the Old Value box and again 3 in the New Value box, and click Add. Enter 4 in the Old Value box and 2 in the New Value box, and click Add. Finally, enter 5 in the Old Value box and 1 in the New Value box, and click Add. Now, click Continue and then OK. You can locate the recoded variable in the last column of the dataset under the name Q5R. Replace missing values. To replace missing values, follow these steps. From the Transform menu, select Replace Missing Values. By default, the method for replacing missing values is set to series mean. However, you can choose alternative methods such as mean of nearby points or median of nearby points. After choosing the method of replacing the missing values, you can enter all the variables in the box and click OK to replace the missing values. In the left-hand box, click Q1. Then while holding down the Shift key, press the down arrow to select items list from Q1 through Q10. Move the selected items list to the New Variables box and click OK. In the output file you can see the number of missing values replaced for each variable. Also, in the Data View window, you can see the newly generated variables whose missing values have been replaced. Compute variable. Once data cleaning is complete, it is possible to compute total scores for each subscales of a questionnaire. For example, to compute the total scores of the subscales of adherence to medical recommendations questionnaire, proceed to the Transform menu and select the Compute Variable command. Remember, computing the total scores of subscales will generate new variables in the dataset. Thus, you need to designate a name for the new variable in the Target Variable field. Choose General for general adherence and Specific for specific adherence. After entering the name in the Target Variable field, double-click the Q1_1 variable from the left-hand box to insert it into the numeric expression field. Click the plus key, and again double-click the Q2_1 variable from the left-hand box to insert it into the numeric expression field. Click OK to confirm. You can locate the newly computed variable titled General at the end of the dataset. To compute the specific adherence subscale, again click Compute Variable from Transform menu. Type the new variable name in the target variable field. Since there are more than 2 successive items to be summed up, utilize the sum command. Manually type the sum command with parentheses in the numeric expression field. Within the parentheses, manually type Q3_1 to Q10_1. Click OK to confirm. You can locate the newly computed variable at the end of the dataset in the Data View window. Saving SPSS data file in tab delimited format appropriate for M+. If you intend to analyze your data using M+ software, you can first input the data into SPSS or an Excel spreadsheet. Subsequently, save the data in a suitable format for M+. In SPSS, the tab delimited format is appropriate for M+. It's important to note that when exporting an SPSS data file to M+, there's no need to replace missing values with the series mean before exporting the data. M+ is equipped with a sophisticated missing value procedure, thus a data file containing numerical missing values like -9, but not system missing values, would be suitable for M+. To accomplish this in SPSS, follow these steps. Select the Save As option from the File menu. Choose the tab delimited option with DAT extension from the Save As Type drop-down menu. Specify a name for the file and then click Save. Exercise 2. I have included the download link for the SPSS file that I used to perform all the data screening methods in the description of this video. To enrich your practice and learning experience, please download this file and utilize it to implement all the skills I taught in this video. Please note that the spoken presentation of this video has been prepared with the help of AI text-to-speech technology in order to improve communication and prevent unwanted mistakes due to ambiguous pronunciation. In our upcoming video, we'll provide an overview of the normality assumption in parametric statistical tests. Moreover, we'll discuss transformation methods aimed at rectifying moderate to severe non-normal data. We'll discover that square root or logarithmic transformations are effective in normalizing right-skewed variables, whereas quadratic, cubic, or exponential transformations aid in normalizing left-skewed variables. I hope you'll find this video informative. Feel free to ask any questions in the comments section and stay tuned for our future videos.